Good evening, everyone, and good afternoon, good morning, wherever you may be joining from. You're welcome to DSA Software Development course. This is the class 21 of the course, so we've had 21 classes so far, and I believe that you guys have enjoyed the class so far. Like you've been impacted in great ways. So we're excited to have you join today's class, and today we'll be looking at continuous development. Continuous deployment, continuous integration, and the role of DevOps. So essentially, we are looking at DevOps and what CI/CD is, and what tools are available when doing continuous integration or continuous deployment or continuous delivery, as the case may be. So I want you guys to help me confirm that you can hear me well. Just type a yes if you can hear me, or drop an emoji if you can hear me. All right, great. Thank you, Deji, for your response. So today, like I mentioned, we'll be looking at DevOps and what CI/CD is all about. But before we go into that, I would like to do a quick recap of our class last week, as those classes will be like a foundation to what we'll be doing today, or some of the artifacts from that class, which is the backend repo that we add from the class and the front-end repository that we add from those classes. We'll be experimenting with them today on how to deploy them. If you remember, we had the application deployed and it was accessible by you guys. You visited the link and you were able to add codes, delete codes, and all of that. So we'll be covering how to do all that. So last week we did look at connecting front end and back end. We looked at state management in React. We also updated the API project that we started some weeks ago. That's the quotes API, which now, after the update, it fetches from the database and is not reading from file when we started the API project. If you remember, we started reading from file where all the codes were stored in a file, but after the update, we connected it to a database that holds all the codes, the ones that you guys created as well. And as part of the update, we also moved to using Express.js. Before, we were handling the requests and responses through some of the codes that we wrote, but we abstracted most of the codes away by porting the API to use Express.js. So we also looked at implementing authentication and authorization to secure the applications we have built. If you remember, we did say that some of the actions that were being performed on the API, like ability to see everyone's codes, ability to delete other people's codes, that those are not a secure way to actually build in an API. An API should first know the people that are accessing it, which is authentication. They should be able to identify individuals that are using it. An app as well, by extension, should be able to identify those who are using it, and you should be able to grant permission to the people that are using it. So permissions such as ability to add new codes, ability to delete existing codes, ability to edit existing code. All of those can be role-based, so you can define permission based on roles. So in the API, we did have user roles, and we have admin roles. And admin are the only ones that can delete quotes. They are the ones that also can, I think they can delete quotes, while a regular user can edit quotes, and so on and so forth. I mean, all of that is just to give you a quick recap on what we treated last week. Okay, so in today's class, we'll be covering how to make the apps and APIs we've built accessible to the world. All right. We'll see how we can make it accessible to the world. So in doing that, in order for us to do that, we will deploy the application. Like I said, the focus of DevOps and continuous integration is for you to deploy the apps or the APIs that you have written. And when we say deploy, you are making it ready and usable for everyone that have access to the link or to the server where you have deployed. All right, so once again, I'd like to welcome you guys to class 21. And in today's class, we have some few learning objectives. The first one is understanding CI/CD pipelines and their benefits, and setting up basic GitHub Actions or other CI tools. And then we explore deployment via platforms like Render and Netlify. And we also describe the different platforms that are available and what solution they also offer, and where they fit into in the landscape of CI/CD. So we will look at all of that. All right, so in order for us to achieve the set objective, there are some outlines that we will consider. And the first one is we look at what DevOps is, although I know I've sort of described it, but we will look at defining it proper. And then we will look at what CI/CD is also. And then we will look at why DevOps. And I think during that point, we will consider the origin of DevOps. And then we will look at where to deploy. And in looking at where to deploy, we'll look at the different services that currently are available. So that's what we'll be covering today in the class. So the first one is what is DevOps? What is DevOps? So I would say DevOps is like a cultural and technical movement aimed at unifying software development, which is the dev aspect of DevOps, and then IT operations, which is the ops aspect of DevOps. So these exist as different roles. I mean, still for some companies, it still exists as different roles where you have a developer just focused on writing code and building software. But I haven't seen the downside to splitting that role, hence the cultural shift into DevOps, right? So at least by now you are familiar with who a software developer is. You are a software developer, but you might be wondering what IT operations entails, right? And for IT operations, traditionally, they were saddled with the responsibility, right, to provision servers. They have the responsibility to keep systems stable and secure. So what do we mean by provisioning servers, right? So after writing your code, I will cite example of the code that we wrote, the API that we wrote, and the one that we were able to access with Postman or Upscotch. You know that we actually had to deploy that to a server somewhere, even though we didn't we didn't show you how we manage the server. So that server where the code currently is resident is what an IT operations person would have provided would have provided or made provisions for where the code will now reside, right? So that's what we mean by provisioning servers. So I started with that responsibility of provisioning infrastructure, and infrastructure would mean servers. It could be load balancers, and servers could be a virtual machine or bare metals. What do we mean by bare metals? So it could be a physical machine somewhere, or it could be that the machine, yes, physical, but has been virtualized. So you're not deploying directly to a physical machine, as it were, but a virtual machine built on top of a physical machine existing somewhere. And during the course of the class also, I know you guys are familiar or might have heard of cloud. And then we will discuss how cloud plays a role in all of this and where cloud fits into all of this. You may have heard of AWS before, Amazon Web Services, or Google Cloud Platform, which is GCP or Azure. You may have heard of all of those. All of these companies or all of these solutions are also geared towards provisioning servers for where your code will reside. So thinking back, a couple of years prior to 2010, DevOps wasn't really a thing. The dev team existed separate from the operations team, right? And that posed a lot of challenges, a lot of bottleneck to how software is being delivered to the consumer or to the customers. So we look at some of these issues that were prevalent with having IT operations separate from development. So one is that the server provision was a manual work. So there was no automation around it. So you have an IT person actually build up a server from scratch. They will have the machine already existing, but installing the OS, installing dependencies that you will need, probably installing a database on the server. Think about the time we learned about databases. You have to install MySQL, right? Or for some of you that installed Postgres. So all of that you had to do manually. Yes, you ran a command, but the command was run on your computer. So that's a manual process. So when IT operation was separate from development or software development, that used to be the case where someone will actually have to physically run commands on a physical machine or a machine that they have remote access to. So servers were provisioned for manually. Like I mentioned, it could be a VM, a bare metal, or a system somewhere that they have to have remote access to. The infrastructure setup was very slow. You can imagine that if a person has to run series of code, have to install OS, and there are times that you are not just dealing with one machine, you have probably tens of them or hundreds of them, and then someone will have to manually go install all the dependencies that a software will need to run manually, right? And you can already see that it would be error prone because humans tend to make mistakes. And I myself actually had a fair share of this. I can remember, I think around 2017 or 2018, thereabout. Although it was fun, right? Like you have written software and then you go on to somewhere like AWS, you have an EC2 instance, or you go on this other one that provides also similar service such as EC2, where you create droplets and then you SSH into the server, and then you pull your code from GitHub into the server, and then you build, and then you set up network, you set up you set up firewalls. I mean, all of that can be fun, but imagine where you have hundred of services that you actually have to deploy. Then think of how hectic it will be to actually go in manually to do all of those work over and over again, right? So it could be error prone. And I remember back then too that each time I have to do this work, I have to go and search on Google key information as to how to go about this or how to go about that. So the entire process was undocumented as well. And having an undocumented process means that other people cannot replicate the process. So everyone that have access to the server would just do what they wish. So new environments could also take days or weeks to prepare. I mean, given that it's all manual, right? So let's say you want to create a staging environment where you can test the software you're building, or provide some stakeholders such as the clients that you're working for, or some select few customers that you want to do A/B testing with. I mean, spinning up a new server to do all of that can take a bit of time, right? And then another issue with such arrangement where operations was separate from development is siloed team structure. Siloed team structures. So I'm going to take a pause after running through all of these issues, and see what you guys are talking about in the chat section, in case there are questions to take or anything you want to draw my attention to. So silo team structure was the order of the day. And what do we mean by that? The developers will write the code and metaphorically throw the code over the wall to the ops team. So in such a situation, you have a developer saying, the code I've written works on my computer, here is the code. Go and deal with deployment. And the reality really is that often doesn't go well, because imagine you have environmental variables that needs to be provided to the IT ops people, but the developer didn't mention it, right? And then they deploy, and then because an environmental variable is missing, a part of the code breaks and all of that. Or the developer didn't mention to the IT ops people that a secret should be kept safe and not be exposed to the world, but then they go ahead and deploy without proper security check. So you can open the software to malicious attacks and all of those. And then there's also little understanding or empathy between devs and ops, because they operated as separate entities, right? And there is no communication going on between them. And also there is no shared accountability for outages or performance issue. I mean, in such a case, you see people pointing fingers and saying, oh, it's the devs' fault, or is the IT ops people's fault, and so on and so forth. There is also infrequent, risky deployment. Because the process is not automated, and because of the inherent potential for errors, because all of this is being handled by humans, right? There is a high chance that when you are doing deployment, it becomes risky. I mean, aside the fact that people, when they write code, they just write code and write a lot of code and wait till the end of the week to do a singular deployment. And the reason why they actually wait until the end of the week is because the process is tedious, and they don't want to be releasing every night and then having to deal with issues every night. So most of the time they wait till end of the week, where they have plenty code, and you see people running frantically, trying to merge in their codes and all of that, so that at least it meets or it ships with the set of features that they have outlined for that week, right? So deployment becomes infrequent and also risky. But the reality of it is that when you actually have your code running in a production environment, um, when I say production environment, when you have your code already live and people are using it, there is tendency that there are errors that will be spotted, right? Or something is just not working right. So in real life, or let's call it real life development, it's such a case that you actually have to be able to quickly respond to errors or quickly respond to your customers if a feature is not working the way they want it to work or the way they expect it to work. Your turnaround time shouldn't be a month or a week. In such a fast-paced world that we are in right now, where people's attention cannot be kept for so long, if you put your customer in such a position where they are waiting an entire week to have an issue fixed, there's a high chance that they look elsewhere for the same solution that you're preferring. So errors or dealing with errors has to almost be an instantaneous thing, right? And such an arrangement where devs are separate from IT ops doesn't provide for such, right? And that leads us to heavy change management. In such arrangement, you have changes requiring approvals, forms, sign-offs, and many things. You even have places where they have change advisory boards. So you have a board sitting and deciding what code should be deployed. So you can already imagine the bottlenecks and all. And then lastly is reactive monitoring. So like I was saying, that when it comes to real life usage of software, things tend to break. But nowadays, when you are using your app, the owner of the app, they actually see how you use the app. Yes, they are not infringing on your privacy, but they have tools in place that knows where you are interacting with the app. Is it that you just signed up? Is it that you are clicking a button and it's not working? Or is it that you clicked a button and an error occurred? So all of those interactions are being recorded and sent back to the developers of the app or to the owners of the app. But prior to DevOps, such was a lot difficult to it was never part of the culture, because even if you do spot error, it's going to take a week or so for a turnaround time to fixing the error. But nowadays, you see that there's something broken in an app, and before you know it, a couple of hours, they probably have fixed it. So part of the issues with separating ops from developer is not having that feedback loop where developers see the real world usage of the app they have built, or see the real-time errors that are coming up in the apps, right? So those are the issues with traditional IT ops. Next, we'll look at the outcomes of such arrangements. But before we do, as I promised, I'm going to look at the chat section now and see if you have any questions. Or someone is saying we should make it bold. I think I'll just turn off my camera so that it's a lot more visible. But again, you have access to these slides afterward, so don't worry too much about it. Okay. For those asking about quiz, I think you should reach out to the admin. They'll be able to address that, or give you a feedback on quiz. All right. I think there are no questions so far. Okay, great. So we'll quickly look at outcomes of such traditional IT ops. And I want us to to cast our mind back to one conversation that we had or in one of our classes. I think it was about gathering requirements, right? I think that conversation was about gathering requirements. And then we said one thing that will really help you in your journey as a developer is ability to actually interact with people, right? And this part of DevOps is something that is heavily reliant on interaction. And thankfully, that the separation that used to exist, or let's call it dichotomy between ops and devs, that has been removed, and that has birthed a lot of benefits. But before then, the issues used to be that there were long lead times for changes. So, like I explained, if there was an error seen in production, it takes a bit of time because there are a lot of hoops to jump through, bottlenecks to cut through, and I mean, you have an advisory board picking what should be worked on or not worked on. So that creates long lead times, right? Then also fragile system due to manual configuration drift. Like I mentioned, if humans are involved, there are tendencies that errors will be introduced. And also another outcome is that there is low deployment frequency. Often you get a monthly or quarterly deployment, which really doesn't catch up with how people use software these days. Especially when they are paying for the software. You see a customer making a request for features to be added, and they expect the features to be available in a couple of days. So you can't afford to be waiting till the end of the month to deploy changes or to add new features. Okay. And then there is a tendency for burnout because of the release process. So if you have just a couple of guys handling operations and people are on their neck saying this thing should be live already because everything is done manually, right? So there's a chance that those guys can get burnt out. And also lastly is the culture of blame when things fail. Ops, we point fingers at devs, and devs, we tend to point fingers at ops, which is not a good environment for work where people are sharing faults and nobody is able to own up to take responsibility for what has happened, right? So DevOps emerged from a need to actually have a cultural change around how software are being deployed, like I mentioned earlier. And the need for change in culture is around the operations of deploying software to the consumer. And the aim is actually to automate the infrastructure deployment. So the aim is automation of deployment to help foster collaboration between the two entities and increase deployment frequency, and then lastly maintain stability and agility. I mean, all of this is stemming off the issues that I highlighted in having a separate ops and having a separate dev team. So all of those issues were meant to be combated by DevOps. So in automating the infrastructure is now provided as a code. When you see automate infra and deployment, and then you see IAC is infrastructure as a code. You know, I was explaining earlier that there was such a time when I think it was just around the time I started professionally programming, that I will have to SSH into a server or do a remote login into a server and then be doing things manually. All of those, like installing OS, you install Ubuntu or you install Linux or whatever the OS you want to install on your server. All of those were done manually. But now with DevOps, you have to automate that, So that's what gave birth to what we now call infrastructure as code. So the same way you write your application code, like your React, or write your APIs, is the same way you write the infrastructure that you want to deploy your applications to as a code as well, right? So say you want a Linux server, you want a MySQL server to be installed, you want Redis to be installed. I mean, whatever it is that you want, you can write it as part of the code. And writing that code also means that you can push it to GitHub like you would your typical application code. And what that means is that it can be code reviewed. So it's not just that, oh, you write and then deploy. Your teammates can actually see the infrastructure you've written as code, right? And it can be applied automatically as part of your CI/CD process, right? So in all of this, what is being automated is the server, the compute resource that you are making available to the application, networking, who has access to what part of the apps and who should not have access, creating databases or load balancers. Well, I think at some point down the line, maybe we will also describe what load balancers are when it comes to scaling your application. I mean, if the cost does reach that point, hopefully it will get to that point. But for now, just know that load balancers allows you to scale your application. So as part of your deployment process, you can define what load balancers should be part of your infrastructure. All right, so that's that for what the benefits are. And I have a table here that further highlights those benefits. Once you have your slide, you can look at it, but for the sake of this class, I'll just run through them. One, it is repeatable, it is collaborative, it is auditable, it is automated, and reduces human error. So those are the things that you get from having IAC, that's infrastructure as code. Now we jump into CI/CD. We've been talking about CI/CD. We've mentioned it quite a number of times, but we have not defined what it is. I mean, what it is really. Yes, we know that it is continuous integration, like I earlier mentioned in the class, in the start of the class, and that it is continuous delivery or continuous deployment. So CI/CD is a development practice and automation pipeline that allows teams to deliver code changes more frequently and reliably. So it's a practice that allows for the automation that actually helps you as a team to deploy your code. So there are two parts to it, right? One is continuous integration and the other one is continuous deployment. And there are different parts that forms the CI/CD pipeline. So we describe each of them so that you know what happens at each steps. So in CI, we call CI a continuous integration. So what that means really is this. You have a team of people working on the same code base, and you have different teams with different responsibilities. So let's take, for instance, our quotes API. You know, when we started with defining some endpoint that allows you to see all quotes or to generate a random quote. So in such a case, let's assume that we are writing this quotes API as a big team, or maybe just a single team, but different people in the team having different responsibilities. So we have a part of the team that are responsible for the random quotes API, and we have another part of the team responsible for authentication, and then you have another part of the team responsible for deleting quotes, which means different people are working on the repository at the same time. What CI allows you to do is that you as a developer, you can push small frequent commit to a shared branch. So you can say that you have this feature branch, and then each one of you can now create a fork from that branch. And as you are implementing your features, you continue to create commit and push to the shared branch. And what CI helps you with is that at every push that you do, it can trigger something like code compilation. We learned about TypeScript and compiling TypeScript, or what we call transpilation. So transpilation can happen automatically, so you don't have to do it manually, right? So the CI pipeline can actually handle that for you. And and not just when, you should have tests as part of your code. So once you push, the CI runs the automated tests, and then in addition to that, you can do static code analysis. I wouldn't know if you guys will remember also when writing TypeScript code, there are times that it will show a red squiggly line underneath some of the code, indicating that there are issues here and there. You can also perform same on your CI pipeline. And your CI pipeline can also help with scanning for security issues. So if there is a code that you wrote that might pose a security issue, your CI can easily catch that. And all of that is happening just to ensure that whatever it is that you are going to deploy is safe for deployment, right? So that's on the aspect of CI. What then happens in CD? Once CI is done, it can actually continue with running further tests. It can build artifacts. So imagine that you're actually building a mobile app. The way you deploy a mobile app will be different from how you would handle a website or a web app. Typically, you will deploy a mobile app to either Google Play Store or the Apple App Store. So part of your deployment will be how to make that app available to those different stores. But when you are dealing with web apps, it's just how to deploy the app to a server somewhere so that people can access it. So what happens during CD or continuous delivery is it deploys your pre-production code to a staging server, and then you can now wait for a manual approval before it goes live. And this is where it differs from continuous deployment. In continuous deployment, everything is automatic. Once you push to a particular branch, say your main branch, or in some cases, if you have legacy code, you push to your master branch, and from there, every other automation is kicked off till you actually have something that is live for your customers to see and interact with. So the goal with continuous delivery or continuous deployment is to ensure that you have a ready to deploy to production code, to ensure that risks are actually minimized and to speed up the time to market, right? So those are the things that happens during, those are the benefits that we actually derive from having a CI/CD pipeline. Again, just think about having to do the same thing manually over and over again. Those are bottlenecks, but if you are able to actually automate it, that makes your life easy, and that helps with speeding things up. So what are the tools that we actually use for this? These are common tools. You can use GitHub Actions, you can use GitLab CI/CD, and then the more popular one, or the standard ones that you typically see on a standard team, you probably see Circle CI or Travis CI or Jenkins. I've not come across Argo CD or Flux CD before, but I do know that there are people using it. Then you have something like Render, Netlify, or Vercel. And then we'll get to understand how all of this fit in together while talking about where to deploy. So those are the common CI/CD tools. The next thing to talk about is where to deploy. In talking about where to deploy, once your CI/CD builds and your test passes, the code needs to go somewhere. And the options that you have in this part is either you are deploying to a serverless hosting, or you are using a PaaS, which is a platform as a service, or you are using a cloud infrastructure as a service, or you are using a container platforms, or you are going to self-host the deployments on your own server, right? And the examples that we have under each type of deployment, under serverless hosting, we have Netlify, we have Vercel, we have Render, which is what we have used so far in this course. The few apps that we have had to interact with, the data structure app that you used to visualize different data structures, that was hosted on Netlify. And then the API that you all interacted with, that was hosted on Render. And why is it called serverless? Because actually during the deployment, never really interacted with a real server. I just pointed to the repository that I want deployed, and deployment happened. I never had to decide or make a choice of what OS should be installed on the server that I want. I just pointed to the repo and the rest was automatically done. But if you need more control, you can consider other deployment options like using Railway or Fly.io or Heroku. Heroku used to be very common and popular, but I think that has been taken over with the recent technology around React and many other technologies around front end, such as Jamstack. So that has made Netlify and Vercel quite an household name. But if you do need a lot more options, like a lot more customization, choosing the right servers that you want, like you want to specify the RAM, you want to specify the storage space, or I mean, generally, if you need more customization, or you want to deploy an enterprise grade software, then you start looking at AWS directly. And the funny thing really is, when you consider something like a Netlify or Vercel or Render, most of them are actually using AWS under the hood, and they are just reselling AWS to you with a markup for the ease of deployment that they offer as value. They either use AWS or GCP or Azure under the hood, right? And by the time you are thinking of scaling, you can start talking about containerizing your software so that when there is high demand or there are more people hitting your software, say you built a web app and when you built it, you just thought, oh, maybe 100 people will use it. But your app became viral and then 1 million people want to access it, right? If you deployed just with the mind that it's only 100 people that would use it, then in your decision making, you'll have decided that, okay, it's fine to put it on a medium computer that is not so powerful because not a lot of people will use it, right? But then overnight, your app becomes viral, and then you have 1 million people trying to visit your page. If your app remains on that small computer that you started with the 1 million people trying to access it at the same time, the server is going to become overwhelmed, really. So that's where containerization now comes into play, which allows you to easily auto scale your app. I mean, it provides you such an option where you can easily scale up your app without experiencing a downtime, without having to shut down the app first and then try to increase the size of the computer that you're using as a server and all of that. So and so on and so forth. Those are the options that are available to us when we now are thinking of deployment. I know someone might be asking the question, so what about our database? We have talked about API. We've talked about the front end app. Yeah, same thing with databases. There are different services that exist where you can host your database. AWS, for instance, provides such a service like RDS, where you can host your MySQL and then they provide you a link to access or connect to your database. So there are such platforms that allows you to host your database as well, and many other services that you may want to host if you're looking at scaling or you're looking at using event-driven system where you now need to have a message broker or something like a Kafka. I mean, all of these things that I'm saying, I know you may not be familiar with it, but I'll just say them. For those of you who are curious enough, you can go check them out. So let's say you want to deploy Kafka, you want to deploy a Redis server, I mean, what have you, or use RabbitMQ just to scale your system up. All of these infrastructure as a service or cloud providers, as we commonly call them, they also provide solutions for those that you can easily use. And then lastly is you can actually choose to self-host. I mean, a lot of people are also moving to that now, where they are taking their platform off AWS, for instance, or GCP or Azure, and they are actually self-hosting. I mean, that used to be a thing before cloud became the rave, right? Companies have server farms where all of the software they are using are deployed to, right? I mean, by the time people now see that AWS can cost too much, and they can almost get the same performance and the same utility if they actually invest in owning their server. So people are also moving away from cloud to self-hosted. But then, if you've invested in learning cloud, your knowledge is not to waste. You can easily apply it. To a certain extent, the knowledge is portable to also handling self-hosted servers. All right, so that's that about where to deploy to. So I'll take a break to look at our questions, and I think by the time we take a look at the questions and also take a break to take our attendance, by the time we come back, we will try to write a simple application and try to deploy them to either Netlify, and then we have a simple API as well that we will deploy to Render, and that will be it for the class. But further to that, what I would advise is, I mean, based on what I've covered so far, I did mention that there are different tools that we can use for CI/CD. I mentioned that we can use GitLab Actions and all of those, right? So what you should do as part of your learning process is to go find out about each of them, right? Check out GitHub Actions, see how it is set up, or alternatively look at GitLab CI/CD. And I think GitLab CI/CD offers you a great free tier to experiment with. For GitHub Actions, I don't know how much they offer on a free tier level. Most of it might be paid for, but if it's paid for, you can switch over to GitLab. GitLab CI/CD to a great extent offers you free access. So do take a time out to actually check all of this out. All right, looking at our questions now, trying to see if There are questions for me. So someone is asking if Netlify is free. So I think Netlify has a decent free free tier where you can still host your stuff, right? And you don't have to pay for it. Just that you may not be able to specify a custom domain and all, right? But they do offer you free tiers. Someone is asking, is Netlify CPU okay? I don't know what that means. You might want to rephrase your question. Yeah, AWS also have a free tier for their EC2 instance. But like I said, when you have an EC2 instance, most of the time you actually have to manually set up things. Uh, the aim of this class is for you not to do things manually, right? So you should look towards actually automating whatever it is that you want to deploy to an AWS EC2 instance. All right, I think that's that about it. So we are like 5 minutes away to 8 o'clock where we take our attendance. So I would just like to take us through or speak through the things that we'll be doing again on the second half of the class. So one, we'll create a small React app and have it deployed to Netlify. And then we create a small Express app too. Or maybe we just use our existing ones. Anyway, I think that would be faster since we all have access to that, right? So I think we should use our existing apps to demonstrate this. So that's what we'll be doing in the second half of the class. So before that point, I want you guys to go to Netlify. So netlify.com, create an account there. It is free, like I mentioned. And also you go to render.com. If I can show you that on my screen. There is render.com and then there is netlify.com as well. All right, so this is netlify.com. Oh, okay. And on netlify.com, you can actually host a couple of projects. Right now, I think I have like 7 projects or thereabout. And this is the project that we last worked on, which is the Quotes app. I think currently it's down for whatever reason. I may need to check that out why it currently is down. And then I also have the data structures and algorithm app, which is also running on Netlify. So what we want to learn is how to deploy such, right? So if you go to the data structure link, you'll still see it running. And the last time I touched it was the last time that we talked about data structures, but it's still there running, even though I didn't have to pay for it, right? Okay, so I want you guys to go to netlify.com, create an account there, And then the other one to render.com, you create an account there. For render.com, that's where we have our API hosted. That's where we have our API hosted. So also create an account on render.com. So if you see, well, for me, I only have one project on render, which is the basic API project, right? And as you can see, I have a free tier and it's still running. So I will take a break from here, and by the time we come back, I'm guessing you guys will have an account already, and by the time we are back, you will have taken your attendance. All right, you guys are welcome back. So I do believe during the short break you were able to create accounts on Netlify for those of you who don't already have a Netlify account, and for those of you who also don't have a render account, I hope you were able to create an account on those two platforms, because we'll be working with those two in this next part of the class. So what I'll be doing is sharing my screen while we walk through this process. So again, I'm trying to see if we can just do something simple, or maybe we just deploy what we have already. I mean, by what we have, I mean these two repository that we already have. So I'm thinking we should just do something very, very simple. So if that should be the case, I think I will create a very simple React app and then have that on Netlify. And I think it's just about the same process also. I mean, something very similar. Like I said, this is deploying to a serverless platform. So there's not so much customization, and with the fact that there's not so much customization means that the processes might be quite similar, right? Anyway, let's start with creating a React app. So I'm just going to use Remix. We've been working with Remix. So let's use, they have a Netlify template that actually set up your Remix app for easy deployment to Netlify. But if you didn't start with this template, you can still figure out your way around it. So in addition to setting up your account with Netlify, you also need to install Netlify. There is a command for installing Netlify. Let me get that for you guys. So what that does is that it helps you to run commands from your terminal. So what you go ahead to do is you do npm install, but it will be helpful if you actually install this globally, right? And what that means is that you will add a G flag, so there will be an -G before the Netlify so that it installs globally. And like I mentioned, what that helps you to do is helps you to run the Netlify command from anywhere in your terminal. So, but for me, I've already done that installation. So what we'll go ahead to do is just create a new Remix app. I believe you can see my console. I'm just going to increase the font so you can see it properly. As always, I have my code saved in developer DSA, and these are the current repository that I have on my local system. So what we'll do is git clone, actually npm remix. We are not cloning, we are running a command that will help us to create. That will help us to create. So remove the git clone. What you just do is npx, this same command that we copied from here. npx create remix latest is using a template, Netlify remix template. So you come over here, paste it in your terminal, then run it. So it's going to ask some questions. You just follow through with that. So it's saying, where should we create your new project? So for me, I'm just going to say test deploy remix. I mean, the name doesn't matter. just giving it a name that we can easily remember. So it's asking if we need to, if he wants us to initialize a Git repository, which is the standard question that Remix will ask you. So I would say yes. If I say no, it really doesn't change anything. What that means is we just have an extra step of doing Git initialization. But I'll go ahead and say yes. It's asking if we should install dependencies with npm. So yes. This template has a remix init script. Do you want to run it? Yes. All right, so we just hold off while that is happening. All right, so whilst we wait for that, I want us to also install an API that we can actually call. So for this one, because there's no template API that I can easily use, so I'm just going to use All right. All right. We have pulled the default Netflix template, right? And we also edited the default page from welcome to Remix to welcome DSA software class, and that will be what we will be deploying to Netlify. But let's hold off here for now and quickly jump over to what we have for our API. Okay, so like I mentioned earlier, that what we are interested in is the first version of this API that was reading from file. And the reason for that is this version is just the bare basics, right? It doesn't have any database connection or environment variable or what have you, right? Which makes deployment quite easy for us. All right. Okay, so let's clone the app for now. Go to code and then copy the link. Then we go to the terminal. Then we see, okay, we're already in DSA, so we just git clone. And let's give it an appropriate name, test API deploy. And that's it. And yeah, that pretty much is it. Let's see what's inside. Okay, so that's it. And in this case, we actually don't need to do npm install because all of that will happen on render. Because typically, we don't need to. Typically, we don't usually upload npm modules anyway. But what we will do now is, I cloned a new repository, right? And we will need to push this repository to render. So now let's just keep this as it is and move over to our React app. And the reason why I'm doing the two side by side is just so that we have enough coverage before the time runs out. Okay, so for our React app, what we need to do next, earlier I said we need to install Netlify globally. So we'll just do Netlify init. And what this is doing is setting up the app for deployment. I will take us back to this point. This file here is very important to our deployment because it's going to contain some details that Netlify will work with. And we have it here because we actually started with a template for Netlify. If you use the default template for Remix, this won't be there. But then your Netlify init will create the same netlify.toml file. So it's asking us the question now, do you want to create a Netlify site without a Git repository? No, I want to connect this to GitHub first. You know what? I think we should push this code first to GitHub. And what we need to do is first create a repository that this will go into. All right. So create new repository. I will call it test deploy remix. and we make it public. All of this is okay. Create repository. Let me make this bigger for you guys to see. Okay, so we already have existing repository, and we won't need to do any of this. So what we just need to do is copy all of this and go back to a terminal and then paste. I will explain what each line is doing. It says git remote, add this origin. So we are adding this origin to this repository, which is called test deploy remix, and then it's branching into main branch, or we are setting up a branch called main branch, and then afterwards we push to that main branch, and that's it. So if we go back to this page and do a refresh, we will see that the code we have in our local has been uploaded, and this is how you confirm. You know, earlier on we edited what's in the index file that you should show welcome to DSA class, and you should see that. Okay, no, you won't see that because we have actually not committed our changes. So if you do git status, you see that we modified the index.txs, so we have to commit that change. And how we do that is we do git add all, then git commit m, can say change welcome text, then we do git push. So on doing that, when we go back to here and refresh, you see that the changes that we actually made is now reflected here. So now we go back to where we paused with Netlify init. We run that code again. I mean, all of this is really simple. So far, what we have done is we created a new React app, but this time around we are using a remix framework, and then we are using the Netlify template. So essentially, we are creating a remix app, but that is suited for Netlify deployment, right? And then we created a repository on GitHub for this app, which we just finished now. I mean, those are the two key things that we have done so far. Then we modified the text on the index page just so that we know that, okay, this is the app that we actually modified locally that is shown. And then lastly, we are doing Netlify init, which will prepare the ground for a deployment. So he's asking us the question, what would you like to do? Connect this directory to an existing Netlify site, or create and configure a new site? So we just create it and configure a new site. He's asking what team do I want it to be. I'll use my default team. He's asking for what name. We can give it test deploy app or deploy remix. Again, the name doesn't really matter. Oh, okay, it's saying that already exists. So test DSA deploy remix. Hopefully this one doesn't exist, and it doesn't. So it's asking us what is the build command. You know, I was saying earlier that in your CI CD process, in your CI you do all manner of stuff, such as you building the app, and I gave an example of the TypeScript API, where you actually have to transpile from TypeScript to JavaScript. In the case of a React app, part of the build process is that it bundles the CSS, for instance. I mean, majorly it does bundling and then transpilation in some cases. For instance, where you have some code that are meant to run on a server. Let's say you want to submit a form, but your form relies on an action that does some manipulation to the inputs that you have entered. Such a function is meant to be run on a server, and Remix is smart enough to know that, or Remix does make a provision for that. So part of the build process is that it transpiles such server actions so that they are runnable, and many other things that happens on a build process. So you just click on enter, and it's going to be using the dist for holding the output of the run build command, and that's it. So if everything works fine, we should be able to see our site deployed, and it gives us an option here that we can do Netlify open, and that should open it on our browser, right? I mean, if everything works fine. Or we can also go ahead to, okay, we can also go ahead to view it in the app itself. Okay, it has opened so it's still building from this that is showing here. So we click on that to see what the build process is like. So if there are errors, it's going to show them here. So it's done initializing, currently doing building. So building is done, that's successful. Now it's going to deployment. Now it was deployed. Okay, it's still running through cleanup, post-processing, and then now we should have a running website. So yeah, this works. You see that the changes that we added is what we see on here. So now if any one of you goes to this link, you should be able to see this app that we have, okay? All right, so you guys can try to visit that link. And you know, earlier I was saying that deployment is the process of making the app you've built accessible to the whole world. So right now, it's not just on my computer that this exists. Anywhere from around the world that you visit this link, you should be able to gain access to it. So this app has been successfully deployed. Now that we're done with that, we'll jump over to what we started with our API, right? So for our API, we have series of branches, and we want to see, currently we are in the main branch. So what we want to do is, okay, so what I would do is change branch to the very first version of the project that we have. I'm going to do some manipulation, which it is a lot straightforward than trying to go the standard route. So what I would do with the basic API repo is this, just so that you guys can follow along. So I said I would change directory, I would change the branch to this use functional programming branch, which contains the basics. So we do git checkout, use functional, use functional programming. So it has switched to that branch. So what I would do is list all the directories inside a project. Right now we have git ignore, readme, we have all this package.log.json and all of those. So what I would do is this. I'm going to copy just these guys out because those are the things that we really need. And the reason why I'm doing that is because when we are doing our deployment to render might default to using the main branch, right? But anyway, let's just continue. If this doesn't work, I'll resort to my original plan of just copying these ones out. So let's jump over to render. So what we've done so far on render is you have created your account. So we want to do a new deployment. It's asking us what type of deployment we want to do. So for us is a web service. So for you, it's going to ask that you attach your GitHub account or grant access to your GitHub account. So in that case, I think I should just resort to my original plan so that we start with a fresh GitHub repository, right? So what I would do is copy all of these into a new folder. So let me check out, let me step out of this folder and move to the parent folder. So right now we are interested in this test API deploy. So let's copy test API deploy to render API. So essentially what I'm doing here is just copying one folder into another, or since we already have this copy of test API, we can just stay here and do whatever it is that we need to do. So let's go back into the test API. The things that I'm not interested in is Git in particular. So what we can do is reinitialize Git or just delete Git entirely. But just to save us the stress, we'll do Git init. So it has reinitialized Git for us. So what we'll now go ahead to do is go to our GitHub account again and create a new repository. And this repository, we'll name it to be test API deploy, right? And then we just go ahead and create. And we'll do the same thing that we did earlier, which is git remote add origin and all of those. So, it's saying that origin exists. All right, so not to dwell too much on this, we'll just go ahead and remove the Git folder, which is this right here. So we'll do rm rf the Git, and if we check again, that should be off. So we don't have a Git folder anymore. And what that allows us to do is to reinitialize Git. So if we check now, we should have that Git folder again, and then we copy this and put inside here. let me see what remote origin is pointing to first of all. Git remote v. Yeah, so it's pointing to the right place that I wanted to. So we just push now. All right. So what should happen now is after we refresh here, we should see our code, which is a copy of the original ones that we have already deployed. We are doing this just so that we demonstrate how deployment of an API works on something like render. So like I mentioned, it's already asking us to grant access. So we'll do test Git provider, public Git repository. All right, so let's go to our GitHub account again and copy this here. I mean, if you just follow the instruction, I think you're good. So it has already connected to the repository and is asking us some questions. The language that we used is Node. So this is a Node server, and our branch deploy branch is main. Our source is our root directory is source, and what that means is that where all our code is in source. That's essentially what it's saying. And I'm checking the package.json to see if there are other relevant information that we need to provide to it, such as build or how to start the app and all of those. Anyway, let's jump back to render. So npm install is asking what the start command is, which is what I was trying to check. So our start command is node dist index.jx, node dist which is still correct. So we'll just choose this since it's just a test. It's just a test API anyway. And I think this should be sufficient for what we need, but let me test it locally to see that there are no environmental variables that we need to specify. So we do npm run start. Okay, we need to do npm install first. I was trying not to do this, but since we want to test it locally, we'll need to do that. All right, so npm run start. Npm run build first before we start. Or let's just do npm run dev, so we won't need to build. But since we already built, we can go ahead and do npm run start. So if we visit this with our API inspect tool, which is the upscotch, we are at 3000, right? So quotes.run/random. So this works without having to specify an environmental variable. So we just go ahead with where we are in render and deploy web service. Let's check the advanced option. Nothing is needed in the advanced section, so we just go ahead and deploy. So on doing this, we should be provided with a link. So this is the link that we were provided with. So what we'll do now is just replace this back portion of the link, or the front portion of the link, and paste the link that we were provided with in render. And if everything goes right, we should see a response here. Okay, I guess it's still doing deployment. All right. All of this is still, you see here that it's saying deploying. So once deployment is done, we should be able to see a response to our server. Okay, currently it says there is an error, and I think I know what the error is, which is the same thing that we saw on the local. You know, I had to do a build first before um, we run the project. So we'll just do right exactly that. So um, in our build script, what we're doing is TSC. So what we'll do in the command that starts, we'll just do a TSC and then run this other part of the command. So let's jump right back into test API deploy and edit it. So we can edit let's see where the edit is. Okay, I think let me zoom out so I get the full experience of render. Okay, settings. All right. Okay, let me zoom in so that you guys can see. So what I was looking for is in settings. So it says npm install, but we also need a pre-deploy command, which is not available to us because we are on a free version. So we just revert to our original plan of running TSC first, and then join that command with what is needed to run the app itself. So we save changes, and after saving changes, it has triggered the build process again, right? And that will continue until it's successful. But while we are at that, I'll just do a quick recap of what we've done so far. I mean, it's not a lot that we did. It might appear to be magic. I can see with the corner of my eye someone saying magic. It might appear to be magic, but it really is not. So what we did so far is this. We cloned an existing API that we had, then reinitialized the repository to point to a new repository. I mean, all of that you can skip if you just create a fresh project. But I didn't want to create a fresh project. I just wanted us to use something that we have lying around already, right? Was why we went through that process of cloning and then removing the Git folder and then pointing it to a different repository and all of that. Okay, then we went to render and pointed the repository in question to render. I mean, we just copied the link here. Per the instruction on render, it says that we should provide a link. So we copied the link to the public repository. Mind you, this is a public repository, is why we're able to do that. If not, we will be limited to just using permissions on render. So we will need to grant GitHub, we will need to grant a render permission to our GitHub account. But since this is a public repository, we can just copy paste into render and it will have access to the repository, right? So after doing that, we went through the settings. It was able to pick this up for us. Essentially what we said was the branch, it was a default to, right? What we said was just the build command, which is npm install, and then the start command, which we did with tsc ampersand node dist. I mean, why we needed to do that was that in our package.json, we said that a build is needed before a start. I mean, from this command here, we said node should run from a dist folder, and this dist folder doesn't exist by default. It is an outcome of running the build command, which is tsc, right? So given that, we need to run a build command first using TSC before the start command kicks in, which is essentially what we have here. So the build command is TSC, right? And then the start command is node run whatever it is in, run whatever is in dist/index.js. So that essentially is what is happening here. So we just combined the two commands with these two ampersand, which now led us to actually having a running API. So now we'll just go over to our API inspect tool, which failed to run earlier because we didn't include the build command. So we just refresh that now and we should get a response. And that is it. We have a response, right? And everything from here on goes back to all the classes we had in the last week and the class before that one. So now you have an API that you can access from anywhere in the world, right? And you have an app also that you can access from anywhere in the world. So now you can go back to the class where we talked about connecting front end and back end, and you can start interacting with your API. You can connect your API to your front end, and it will fetch you your quotes and the likes. I mean, this is what we did, that we landed this beautiful quotes quotes app, right? You can view all quotes if you're logged in, and you can view random quotes if you are not logged in, and all of those. So essentially, all that you see here went through the process that I just showed you, right? Okay. And that's that with that. So I will take a pause to look at our questions, if there are any questions. And if there are none, then I think we landed well in this class. Let's see if this is still serving response. Mind you, this will fail intermittently because render on their free tier. You know, I did explain that this is all serverless, and one of the characteristics of serverless is that it doesn't run indefinitely. When it senses that you are not using, for instance, your API, it powers down. It powers down whatever server your code is running on, just so that you can save on money, right? I mean, take for instance some platforms that offer serverless solution like AWS Lambda is a serverless solution, and how they price their serverless service is that the amount of requests you make to that service is what they charge you on. So when you're not using it, it powers down, and this is what actually happens with this app. I know some of you might have gone there sometimes and see that, oh, it's saying this function has crashed and all of that. So what is happening is that the API powered down, and then it's causing an error on the front end. But now that I have visited it, it has powered up again. And if I reload this page, you see that the error goes away. But all of this we can mitigate if we actually are paying for the hosting, right? But for now, it's just for demo purposes, right? So we are fine with using the free tier. Okay, so I will go ahead to look at our questions if there are any. Okay. Don't feel lost. You can go back to the video. I don't think we did anything here that is overly complex. You can always go back to the video. And again, I tried to explain the process that we went through, although it was a bit fast. But essentially what we did is cloned a repository, or essentially create a new project, and then point those projects to either Netlify. For Remix app, we pointed it to Netlify. And then for the API app, we pointed it to render, and voila, we have our hosted app and API. So nothing too complicated, just try to break it down. All right, I'm awaiting your questions if you have any. And again, you guys should try and use the discussion feature on the LMS. I mean, for those who have used it in the past, you can attest to it that you got good help from there, because you can carry on with conversation. If there are helps or if you're stuck at any point, I can easily, or any of the other instructors can easily guide you through. So utilize the resources that you have available to you. All right, I see that we do not have any question, but I'm hoping that the lack of question is not because we do not understand what we've done tonight. But again, if you feel like you are confused or lost, do try and reach out in the LMS using the discussion feature. So that's that for tonight's class. So far, we've been able to cover the objective that we set for the class, which is trying to understand CI/CD pipelines and their benefit, and then to set up a basic GitHub action or other CI tool, which we implicitly did. I will show you what I mean by implicitly did. So for every of the deployment that we did, there is a GitHub action that was run, even though we didn't set it up, especially for Netlify. If you go back to the GitHub repository, you might actually see the things that Netlify did on the repository itself. But because we didn't go through the normal route of using Netlify or the normal workflow for using GitHub with Netlify, which will be that you create a branch for features that you want to implement, then you do a pull request, and from that pull request, once you do the pull request, Netlify triggers on that branch and creates a link for you to see the changes you have on that particular branch before you merge and before you deploy it to production. I mean, that would be the typical workflow. But since we didn't do that, you may not actually see that part of Netlify. But let me go to the project to actually see what happened on the end of Netlify. So we have our test deploy remix, which is the one that we're interested in. Okay, because we never created a pull request, so we won't see the actions at play. But then when you do set up actions, this is where you would typically come to add actions. Now, if I search for Netlify, I should see it as part of the actions. Okay. No workflow. What about deployment? But anyway, all of these are open to you researching and checking it up for yourself. But you can see all of the workflows that you can actually do or attach to your GitHub actions and likes. Anyway, so back to the objective that we had set for this. We were able to explore deployments to render and Netlify that we were able to really cover. And I do hope that with this much that we were able to do in the class, that you can begin your deployment journey and also serve as a basis for learning further when it comes to CI/CD. I mean, we've not even touched on writing tests and showing the test result, or doing code coverage to check the code quality you have. I did mention checking for security issues in your code base. You could use something like, there are several tools that can check for vulnerabilities even while you're still coding. And you can set up catches on your GitHub repo that won't allow a pull request to go through unless those security issues have been addressed. So that's that for this class. And then in the next class, which is tomorrow, we'll be looking at software testing, unit testing, and integration testing. So we hope to see you tomorrow. Do have a good night and enjoy the rest of your day.